In number 50, we are to sketch the graph of the piecewise defined function. We are to try to do it without a calculator and then give any points of discontinuity. So in this piecewise defined function, we have the absolute value of x if x is less than 0, and we have the function x squared if x is greater than or equal to 0. So I'm going to start by making a table of values for the first part of the function, which is y equals x, in the area that the domain is defined. So that's any negative number, so like -4, -3, -2, -1, ending at 0. Even though 0 is not included in the domain, I do want to know what the value of that function is at that point. So substituting those in the absolute value function, I get 4, then 3, 2, 1, and 0. So I have a line with a slope of -1, and so at -4, I'm at 4, so I have a point there, then one at 3, then one at 2, one at 1, and I have an open circle at 0. If I can get the thing to draw for me, there we go. So I'm going to draw that line, which is going to be like this, and I'm not going to continue it on the other side of the graph for the positive x values. Then I'm going to make a table of values for x and the other part of the function, which is y equals x squared. So I'm going to start at 0 where it is defined, and then choose positive values, 1, 2, 3. So substituting those values in the function gives me 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. So now at 0, I'm going to fill in, so to speak, that open circle. So it is going to be a closed circle. I think I need a thicker pen here. Having trouble making a closed circle there. There we go. So there's no longer a hole there. Now we're at 1, 1, and 2, 4, and 3, 9, right there. So I'm going to draw that parabola like that, and it should be connected. There we go. So the graph will look something like that. And as we can see, there is no point of discontinuity because the two graphs are joined, and they're joined with a closed circle. So we would say that there are no discontinuities. Now, let's say it was more complicated functions, and we would want to put them in our calculator. So starting with the 84, what we want to do is put each piece under a separate function. So y1 will be the absolute value of x, and y2 will be the x squared. Now we enter it in a certain way so that it only graphs the part of the domain that we want. Now we're going to put it in a fraction, so a nice way to do it so it's easy to follow is to create a fraction template under y1. So that's under alpha y equals. And then in parentheses, I'm going to put the function, which is just x, in the numerator. And in the denominator in parentheses, I'm going to put the restrictions on the domain. And the restrictions are that x is less than, and the less than is under second and math. That's my test menu. So less than 0. And I close that. Then I'm going to go down to y2, and I'm going to put the x squared part. Now I can do the exact same thing and set up a fraction template. But if I don't want to use a fraction template, I can use the division symbol. So I'll do this part using the division symbol so you can see how, even though it looks differently, it'll give you the same results. So my function for the second part of my piecewise function is x squared, which I put in parentheses. Then I'm going to use the division symbol, and then in parentheses, I'm going to put x is greater than or equal to 0. So I hit second math for the test menu, and I want greater than or equal to, and then I'm put 0 and close the parenthesis. And now when I hit graph, I will see that I did something wrong. Hold on. Let's see what I put in here. Oh, I forgot the absolute value symbols in my function here. So let's just change that. Sorry about that. To get the absolute value, I go under Math, go over to Number, choose absolute value, and then I'll put the X in there. And now when I hit Graph, it'll be exactly what we drew on our paper. There we go. There's the absolute value line, and there is our parabola.